NACA was America's first civilian aeronautical research laboratory. Over 100 years ago, their engineers worked right here in Hampton, Virginia. They developed wind tunnels to study wing shape and plane surfaces, which resulted in better, more advanced aircraft. In the earlier days, they created a catalog. What shape of wing would make a plane fast and maneuverable? And how would you change that to allow a plane to take off on a short runway or carry a heavy load? Their work was revolutionary. And when the time came to go into space, the transition was natural.
During the middle of the space race between the United States and Russia, the decision was made to create the National Aeronautics and Space Administration. So the old NACA was rolled into what then became the new NASA in 1958. And the Space Act was created, and it was really the beginning of America's human spaceflight program. And what was really exciting for us here at NASA Langley is that the Americans' human spaceflight program started right here. It was the first class of astronauts, the Mercury 7, all the early days of that fundamental research of how do you put a human into space and get them home safely. All of that started right here. So it's pretty awesome to be walking around here at Langley thinking that you're walking in the footsteps of Gus Grissom and the other Mercury 7 astronauts. So here at Langley, there was a couple of key areas that we focused our human spaceflight research on. One was helping the astronauts train and learn how to land on the surface of the moon. And we did that right here at the gantry at the Lunar Landing Research Facility. So in this facility, we had a simulated landing craft that the astronauts that were hooked up to cables and would swing from this giant facility, and the astronauts would safely land it. We turned the surface of this facility into an exact replica of the moon. They did a lot of their training at night. They would do it in the darkness of Hampton, Virginia in the 1960s with really bright spotlights to try to capture that darkness of space with the brightness of the sun. So they did everything that they could do right here to try to make it as close to what we thought it would be like operating on the surface of the moon. So some of those first images that came back of the moon were taken by Langley's Lunar Orbiter and those project satellites that were up there. And those original black and white photographs that came back, which were very different than the ones that were shot later on by the Apollo 8 crew of the famous color photograph of Earthrise. But the original one came back black and white, and it was the very first look back at Earth from another celestial body. So it grasped the imagination of the world, and it was called the photo of the century. So another key research area that we had here at Langley was how do you teach these astronauts to rendezvous two capsules in space? So they had a lunar lander which went to the surface, and then when it would come back up, it would have to connect with the command module. So when Buzz Aldrin and Neil Armstrong went to the surface, Michael Collins kept that command module flying around the moon. And then when they launched back up off the surface, they had to connect the two in flight, in orbit. How do they do that? So we were able to create a simulation of that here in the hangar at NASA Langley, and every Apollo era astronaut learned how to do that here. One of the things that the researchers and the engineers and technicians here at Langley have always tried to do is create environments and testing and training that is as close to what we think it is going to be like in space. So whether it was simulated landings on the lunar surface to learning how to rendezvous and dock in space, they approached it trying to make it as real as possible. And I think one of the greatest compliments they ever got was when Neil Armstrong was asked what was it like to land on the moon. He said it was like Langley.